So everybody, good evening. If you can hear me and see my screen, can you please say hi on live questions channel? Oh, okay. Okay, so let's wait a couple of minutes for the others to join, and then we'll start at 7:05. Yeah. It's because of the light. That's why I look red. So if anyone can share the web link with Marcel. Okay, so before we start, I just wanted to tell you that today we'll continue with object-oriented programming concepts, which is inheritance, and mostly with abstraction. Okay, so abstraction, when we say abstraction, we're going to talk about abstract classes and also interfaces. So when we use interface and when we use abstract class. The time it's 7:04. Let me also bring my charger here. Yes, I've started. Okay. And also another thing that I want to make sure before we start. So again, I want you to just pull the code from the GitHub repository. So please don't copy and paste classes, because I mean, you can do that, but it's easier if you just clone the repository once, and then every time that there is an update, you can just pull the code. So you don't need to copy paste pages there. Okay, so most of you have probably done it, but I just want to remind you. And also another thing is that I'm here in Florida with my family, so if my kids come here, I lock the door, but they might come here, and then so just disregard my kids, okay? Okay, so should we start? What do you think? Yeah, if you're in Florida, okay, I'll send them. Okay. So it's 7:07. I think we should start, and then so the others, if they come late, they can just join. Okay. So today, again, I just want to mention that today we're going to talk about inheritance and the abstraction part of inheritance. And then when we say abstraction, we mean abstract classes and interfaces. Okay. And again, if you have any questions, you can always use live questions channel. I'll try to check once in a while in my phone here. I don't have a second screen, so I just use my phone. Okay, so let's start with a new package here, and then say Java preview 2. Okay, and then just let's start with a simple example. So let's say we have what we did last week. We talked about employee, and then we had we had a person, student, and a teacher. Okay, so these classes inherited the person. So if we don't want the person class to be an object to be created from the person class, because that's an abstract concept, we cannot create a person, but we can create a student, we can create a teacher, we can create a man, we can create a woman, so a baby boy or baby girl, but we cannot create a person, right? Because it's an abstract concept. And also some of the things, different classes, they just do in different way. So that's why when let's say we have an animal class, okay, new class, and then say animal. And then we know that animal public void and then sleep. So we know that animals, all the animals can sleep. Okay. And also we know that they can eat. They all eat the same, so we can implement these methods, public void and then eat. So all of them, they just eat. Okay, but when we say talk, we don't know how they talk, because every animal, they talks in a different way. Okay, so public void talk, and then since we don't know how they talk, we can just leave this one empty, and then we say, okay, the subclasses, the classes that inherit the animal class, they will implement this class. Okay, so after that we can say new, and then let's have animal demo, or let's say barn. Okay, barn class, and then here, so now we can create an object from the animal class, right? So animal, we talked about constructors last week, so this one, since no instructor is declared here, so this one has a default constructor, a constructor with no parameters. Okay, and then here we can say, okay, animal, and then let's say ask for a sheep, and then, or let me see, let's take easy pets, D for a dog, and then new, name this one dog, new animal. Oops. Okay, so this one creates an object, an animal object, and then they say dog dot sleep. Okay, did we save this one? Okay. dot sleep. Okay. Something wrong is happening here. Okay. So of course, now we have to have a main method, right? So we just started without main method. Okay. So main. Let me just close these things. Okay. And then put these things here. So this is a basic mistake, right? Sleep, and then dog dot eat, and also dog dot talk. These are the three methods that dog object has, dog class has. And then if you see, like, for eating and sleeping, they do something. So they're eating and sleeping. For talk, they're doing nothing. Okay. So since we are doing nothing here. Yeah, thank you for reminding me for the main method. So since talk method is doing nothing here, we can just say, okay, you're not going to implement it. So abstract, of course, if I can write it, abstract, and then so this one says that this method will be implemented from the objects that will inherit this class. Okay, and then since we have a abstract method, then this class should be abstract. Okay, abstract. Yeah, of course. I'm just going to copy paste this one because I'm lazy. Okay, so we're saying, okay, this class is an abstract class because this has an abstract method. Okay, so this one also, if this one doesn't have any abstract method, still this can be an abstract class, which means that you cannot create an object from this class. Now that this class is abstract, so here, okay, we don't have talk here, but here, as you can see, we cannot create an object from this class because this is an abstract class which doesn't let you create an object. Okay, but if we say that this has at least one abstract method, so we have to make this class abstract. And then if we make this class abstract, so now we should, if we want to use this one, if we want to create an object, we have to inherit this class. Okay, so let's have another class here. Okay, let's say dog, and then this class dog extends. Oh, I can write extends animal. Okay, and then here we see an error here saying that, okay, if you're extending animal, this animal class has these two methods that are already defined, but also this class has a method which is an abstract method which has to be implemented if you are extending this class, unless you also are making abstract. Also, let me just copy from here. I don't want to write abstract. Okay, so also you can make this one abstract. So if this one is also an abstract class, so you don't have to implement this one. So it means that this dog class also has these three methods. Two of them are implemented, one of them is not implemented. Okay, so and then here you can add other methods which are different. But we don't want this class to be abstract. We want to have a normal class which will be implementing. Okay, so if you click here, you can implement this one. So you have to implement talk method. Okay, and here you can say, since a dog talks different than the other animals, so for every animal you can say, okay, this one is implemented in a different way. Okay, and then we say here poof, right, for the dog. And then here of course, as you said, this animal class is an abstract class, so you can create an object of any class that are inheriting this animal class. Okay, so you can create an object of dog and say, okay, now we have a reference here of type animal, but we create an object of class dog. Okay, and then this one, if we save this one now and run, and then if you see, so sleeping, eating, and then the dog when it talks, let's say dog here, dog woofs, or dog says woof. Okay, okay, and then here also we can create another class, okay, which is cat, and then this class will also extend animal, and then of course this class has to implement the talk method, which is cat says meow. I don't know how you say meow, but I guess it's like this. Okay, so dog says woof, cat says meow. Okay, let me save all of them. And then here in the barn, we can also have another animal, which is a cat. Animal cat equals new cat. So again, we can have an object of type animal, and we can, a reference of type animal, and then we can create an object of type cat and assign to that reference. Okay, and then again, that we have cat dot sleep, cat dot eat, and then cat dot talk. And if we run this code now, then you can see that they sleep the same, they eat the same, but they talk differently. Okay, so do you have any question till now or any suggestion? Okay, anybody has any question, anything in their mind? And also these classes, they can implement the methods from the animal class, but also this can also have different. And also let me just do this one. Okay, in animal class, let me also add another method, which is move, right? So every animal moves in a different way. Let's say dog and cat. Okay, let me also implement the new method now, which is move. Okay, and then we can say dog runs with 4 feet, and then cat also. Again, this override here is just a decorator. It's called decorator, so it shows that this method here is overriding a method in the animal class. Okay, and here we can also say cat runs. But we can have another animal, of course not in the barn, but anyways, a snake. A snake sleeps, a snake eats, and then when they talk, they say his, I think, right? Snake extends animal, and then since this class extends this abstract class, so this one has to implement the two methods, which is talk and say snake says it's, I think, and then move. How does snake move? Does anybody know the real verb for the, do they crawl or what do they do? Rattle, okay. So snake snakes don't run, they rattle. Thank you. Okay, and then here in the barn, let's say we also have another animal. Let me say cat dot move, and then let's have another animal, snake equals new snake, and then snake dot talk and snake dot move. Okay, so we don't need the others because we know that they're the same. Okay, so here are cat, so cat sleeps, eating, and then says meow. Snake says hiss, and then cats run, but snakes don't run, they rattle. Okay, but also if we want, so even though these two methods are implemented, so if let's say snake sleeps in a different way, okay, so we can also override the sleep method. Okay, so how we do it, we say public void and then sleep, and then this one, you see the sign here, means that this one is overwriting the sleep in the parent class. And then let's say, let me format this one. And then let's say snake sleeps for 3 months. I don't know. Okay, so they sleep in a different way than the other animals. So here in the barn, we can say snake dot sleep, and then let me just say here. So let me put a space for every animal. Okay, and then here you can see the cat sleeps and eat, but snake, they sleep. Snakes sleep for 3 months. Okay, so snakes, let's say snake. Okay, so the question is, why do we need abstract class, right? So we have the first thing is that when we have some methods that we can implement, okay, and then we know that's the same for all the classes that inherit this parent class, but also we have some methods that we don't know how they are implemented, so we can just declare them but not define them, which means we can say, okay, whichever class will extend the animal class, this will have to define the talk method, okay, unless they are also abstract. So if they're abstract class, so they don't have to define it, they can just go with it, then just keep it abstract. But if they have to, if you want to create an object from that specific animal, let's say, so you have to implement or define the method in the parent class, the two methods that are abstract methods. Okay. Okay. So let's let me give you an example so that you can do it on your own, and then we can do it all together. Okay. So because we want the class to be a little bit interactive. Okay. So last week I gave the assignment for so some of you did it, the assignment for the shape, right, or the circle. So Now I'm asking you, let me write it here. Okay, new, and then class. Let's have an abstract class. Abstract. Okay, I'm doing it right. Abstract. This class will have a color, which is string. Okay, a color string. Let me put this one in front of it. Okay, this should be an abstract class, and then we'll have two other classes that are again abstract classes, which is class shape 2D, which means two-dimensional shape, and then we'll have another one, shape 3D. Okay, and then in shape 2D, we'll have a method which will be get, and then of course shape 2D will take okay, no variables, so we'll have only a method which is get area. Okay, which can be in integer or in double, let's say. Okay, and then shape 3D, also this one will have get or compute, whatever you can call perimeter. And then shape 3D will have also another method, two methods, this one also get area, because also 3D shapes, they have an area. And then another method which will be get volume, right? Because 3D shapes also have volume. Okay, which they will return double. Okay, and the same for this one. And then I'll give you 10 minutes to do this one. And then after this one, these are also abstract class. Okay, so this one is also abstract. And then after this one, we'll continue to have a couple of classes which will inherit the shape 2D and shape 3D, which can be circle, square, rectangle, and then for 3D shapes we can have a sphere, cylinder, and a cube maybe. Okay, and then we'll continue building up on this example. Okay, so I'll give you 10 minutes, and then whenever somebody does and says done, maybe I can continue. Done. Okay, but we should give some time to the other students. Okay, I'll not give you 10 minutes, I'll give you 5 minutes. Okay, at 7:35 I'll be back and then continue with the example. So if you're done, you can on your own, you can continue doing the classes which will implement these methods, which will be like circle, square, and then cube and cylinder. Okay. Okay, I'll be back in 5 minutes. Okay, I'm back. So these are my two sons. They wanted to say hi. Just say hi. Okay, you can go and play now. Okay. So they don't disturb the class. Okay, let's see if there is any question or anything there. Okay, is there anybody else done or just Tolly or Tola? I don't know how it's pronounced, sorry, but. Oh, okay, so you want me to zoom the screen, sorry. Is it better now? Okay. Okay, can you hear me? This online, yes, okay. Okay, so because teaching online is so difficult because you cannot get any feedbacks from the students. So if you're done, you say yes. I think that's yes for done and also yes for here listening to me. Okay, so let me finish the animal example. Just, I mean, show what it's done in the animal example so that, of course, I could know everything there, but just to make sure. So animal, again, animal class is an abstract class. It has two methods which are implemented and two methods which are not implemented, which means that these two methods will be implemented from the classes that will inherit this class, okay? So this is, it's called also a contract, okay? So abstract class and the interfaces which will go later through the interfaces. These are called contracts, okay? So there is a contract between the class and says, if you're gonna inherit me, you have to implement these classes, okay? If you want to be a class that will be created an object from it, you have to implement me, okay? Which means that, so why is this an abstraction? We know that animals can talk, we know that animals can move, but we don't know how they talk and we don't know how they move, okay? So dog, it already has these two methods which are inherited from the parent class, but also this animal will define or will implement the two methods, which is the talk and move method, okay? So these two methods are implemented in the dog class. These two methods are implemented in cat class. They can be the same in dog class with cat class, but they can be different. And then we also have another class here which implements these two new methods and also overrides. We can also have this decorator here, which also, this also overrides the sleep methods because the snake sleeps in a different way, okay? So, but of course, this is most important. This class has to implement these two methods, okay? And then in the barn class, which is the demo, animal demo, we can create a dog and assign to an animal reference, okay, which is the reference, which is a parent class. This is upcasting, okay? So we can create a cat and assign to this reference, and then a snake, and then we can call all the methods that are in the parent class or that are in the child class, okay? So this child class can also have extra methods which are different than the parent, okay? But of course, the most important thing that this has to be implemented. So let's go to the shape example, okay? Okay, let me see. Okay. Okay, so these two are unimplemented. Unimplemented, okay? And then they are implemented in the child class. Okay, so let me close this example. I think this is clear. Let's continue with the shape, okay? With the shapes. I mean, these are standard examples. I'm sorry that if you've seen these examples many times, but that's how we can explain. I'll try to find also different examples, but these are like the standard examples, let's say, okay, that are always used. So we have string color. Oh, this is ready. I don't need to do anything here. And then this shape. Okay, since this get area is the same for 2D and 3D shapes, this can be done in the shape method, can be declared in the shape method, or can be declared in the 2D and 3D. So since this is the same and will return the same thing, we can just declare it here, okay? And say public. Okay, let me say abstract. So if you have a shape, you can get the area. Of course, we're talking about 2D and 3D shapes. We're not talking about points and lines. So we'll definitely have a get area. How the area is calculated, we don't know, because the class itself will implement that one. Okay, so circle has a different way of calculating area. Square has a different way, and then the 3D shapes also have a different way to calculate the area. But all of them will have to implement this class. Okay, this method. Sorry. And then let me just write here unimplemented for now. Unimplemented. Okay. So, and then now we can have another class, which is shape 2D, right? Let me just copy this one. I don't want to write it down again. And the new class and say shape 2D. And here we can say it's abstract. Okay. And then here we can define which class it is. Inheriting. Okay, so here we can say, okay, this is inheriting shape. Okay, and then finish. So here you can say, okay, see, shape 2D extends shape. Okay, and then this one has already implemented the get area. Okay, so let's say here we don't want to implement get area, because since this one is still abstract, so you don't have to implement get area here. But also I want to introduce a new method here, which is public abstract, and then double, and then here say get perimeter, right? Perimeter. So let's say 2D shapes, they have perimeter, but 3D shapes, they don't have perimeter. Okay. So here also this one has, as you can see, we didn't have to implement the get area method, because this one is still an abstract class. So still we don't know how to implement the get area method. But also we also introducing a new method, which is get perimeter, which is a new one. Okay, and then we can have a new class here, new class, and then say, oops, so I should say shape 3D, and then here I can say it's abstract, or I can just type it there. Okay, this helps me do it. And then shape 3D also extends shape. Okay, and here we have a new, and again we didn't implement get area. It's still unimplemented in shape 3D, but we want to define, actually not define, declare a new method, which is get volume, right? Public abstract. Wow, I was able to write abstract and then get volume. So here we have a new method, which is, if we say that this one is not abstract, is not possible, but because we have the volume method, which is abstract. Also, even if you don't have this one, we have a method which is in shape, which is not implemented yet, which is the get area method. Okay, so this one has to be abstract because it has two abstract methods. Okay, so now we're done with this method. It was easy. Oh, okay, see, even I needed 5 minutes. but he did in 30 seconds. Okay, now after creating 2D shape and 3D shape, we can create an object, a 2D object, which is a square, which is easy one, right? Or let me just do rectangle first. Rectangle, okay? And then, okay, we can say here, okay, I want to implement shape 2D class. Okay, so here you can say it, or you can just do it in the class. But it's easier here to do. So you say class rectangle extends shape 2D. So if you are extending shape 2D, you have to implement two methods: the get perimeter, which was in shape 2D, defined in shape 2D, and get area, which was declared, sorry, in shape class. Okay. And then here, if we have a rectangle, of course, we have to have two parameters, right? So we have to have a class method, sorry, rectangle, which should be, this is a constructor. And then in the constructor, we have two int, or it can be double, doesn't matter, a and int b, or height and width, right? And then if two parameters come here, we can have int height and width. Okay, and then here we can say, we don't need to say this dot height equals a, because since the name is different, so this variable here is not hiding this variable, so we can just say height is a. So the first parameter is going to be assigned to the height, and the second parameter will be assigned to the width. Width equals to b. Okay, and then if we want to get the perimeter, what is the perimeter of a rectangle? Return 2 times a plus b, right? A plus b. Okay, or 2a plus 2b. Oh, sorry, not a plus b, because we have height and width. A plus b are in the constructor. Height and width. Okay. And what about the area of a rectangle? Is a times b, right? A times b. Okay. Now again, not a times b. We don't have a and b here. We have height and width. Height and width. Okay, and then let's have a class here, shape demo, right? Shape demo. So we can say we have a shape of type shape, and then s1 is equal to new, and then let's see rectangle here. So let's give two parameters to it. So the height is 6 and the width is 4. Okay. And then s1 dot, again, we forgot main. Did anybody remind me about main? Let me see. If nobody reminded, oh, I see, nobody told me. I see, Mr. Asim, you have to tell me that I forgot main again. Main method. And then here we can start working on our shapes. So shape1 dot, we can get the area. Okay, and then say double D equals the area, or double area 1, and then double, and then perimeter 1 equals s1 dot get. Oh, did we implement perimeter? So get perimeter is implemented here. But of course, perimeter, you see, since shape has only get area, if we want also to get a perimeter, we have to declare in shape demo, we can say, okay, this is a shape 2D. Otherwise, so now we can say get perimeter, right? Because a 2D shape has a perimeter and an area. The shape has only an area, okay? So this is something that you should be careful when we use the parent class or the parent of the parent, okay? So here we can say we declared S1 of type shape, and then we created a rectangle and assigned it to this S1, and then we can only get the area of this one. So here you cannot get the perimeter, right? Oops, what happened? Sorry. Get perimeter is not able, but we can change this one to shape 2D, right? And then S2, let's say, okay, is equal to S1, and then we have to cast this one, shape 2D. Okay, so now we're converting this one, because since this rectangle is the child of shape 2D, which is also a child of the shape, so we can convert this S1 to shape 2D, and now this one we can get the area, S2 dot get area, and S2 dot get perimeter. Okay, so in case if we want this object S1, which is of type shape, but actually is an object of a rectangle, then we have to convert this one, which is called upcasting, okay, to shape 2D. So in that case, since we will have to get the area and the perimeter, so we can just declare this one here at the beginning, okay, and say, okay, this is a shape 2D. And then we don't need this cast here. And then just say double perimeter 1 is equal to S1 dot get perimeter. Okay, and then we don't need this upcasting and everything here, okay? I don't know if it's too easy for you. I don't have any feedback or anything. I'm just going to continue like this. Okay, so now we can also have another shape, which is a circle, right? Shape 2D. And then let me continue here. So new class, and then say circle, which will implement. We can just do it here, or we can just leave it here and then implement here and say this one extends shape 2D. Okay, so circle is also a shape 2D. So this one, since this one extends shape 2D, it has to implement the methods of shape 2D, the abstract methods, which are unimplemented methods till now. So now we're going to implement them. And then for a circle, again, we have to have a constructor here. Okay, public circle. And then what are the circle only has a radius, right? So int radius, it can also be double, doesn't matter. And then int r. And then if we say radius here, int radius, again, let's repeat what we learned last week. So we have to say this dot radius, because inside this method, this variable is a local variable which is seen only within this method. So within this method, when we say radius, we mean this one. If we want to mean this radius, which is the global variable, which is the class variable, then we have to say this radius equals radius. Okay. And then when you get the perimeter, what is the perimeter of, also let's declare in here pi. Okay, double pi equals 3.14. We can go deeper, but okay, return pi times radius, right? And then radius, what is the perimeter? So 2 pi r, sorry, 2 times pi times r. Okay, so this is, let me format the code. So this is the perimeter of the circle, and then here, what is the area of the circle? Pi r square, right? So pi times radius times radius. Okay, we can also say use math square, but that's a different topic. Okay, and then here, again in the shape demo, we can also create a second one, shape 2D. Again, we know that we'll have the area and the perimeter because the circle is a 2D shape. S2, sorry, S2 equals new circle. And then you have to give the radius, which is 2. And then again, we can have the area, S1 dot get area. And then S1, sorry, dot get perimeter. Okay. And then we can print them. So here I want to, okay, let me just finish this one and then do the other thing. So let me see if there is any question or any feedback or anything. Okay, so there are guys who know the perimeter and the area of the circle. This is good. Okay. So we can just print here, right? We can just print the area. And say area. Oops, sorry, just inside. Equals, and then just get the area of the rectangle, and then the same for the perimeter. I can just say a rectangle area and a rectangle perimeter. And then the same here for the, okay, let me put a plus here, sorry. And the same for the area of the circle. Circle area and circle perimeter, okay? And then this is S2 dot area and S2 dot perimeter, okay? And then if we print, and then we see rectangle area is 24, rectangle perimeter is 20, circle area is, wow, the area and perimeter of this circle is the same. See, we found a cool circle with the same area and perimeter, okay? Okay, so that you do something, I want you to continue with the task. Can you please create, okay, we'll also do them together. From the 3D shape, you can create two objects. One is the cube and one is the sphere, okay? So let me write down here. Let me see if he's done. Okay, if you're done, just let me know. I'm waiting for it to be done. Okay, so create a sphere and then also a cube. So, and somebody, I don't know, you can search how we get the volume and the area of the sphere. I think it's 4/3 pi r cubed, something like that, but just let's search in the Google, okay? So please create two objects. One is sphere and one is cube, and both of them should should implement the methods, the unimplemented methods of shape 3D. And then here in the shape demo, we'll continue to do the area. I mean, to do the area, yes, the area and volume of the 3D shapes, okay? So I'll give you 10 minutes, 9 minutes actually, 9 minutes. At 8:10, I'll be back, okay? Maybe I'll show my daughters at 8:10, just bear with me. Okay, so there was a question, so let me go back here. So we have to implement sphere and cube, which will extend shape 3D, okay? So sphere and cube. So I'll leave this one open. go. Hey, I'm back. This is my daughter, Bessa. Bessa, say hi.
Hi.
Okay, say bye.
Bye.
Pachim, go to mommy. He can mommy say Pachim. No, you can go yourself. Okay, so let me see. Let me check. Oh, I see. I know the volume of the sphere, 4/3 pi r cubed. Okay, so let me also do it with you together. So we have to create a 3D object, the sphere. Okay, so new class, name is sphere, and here we can declare that I want to implement shape 3D, sorry. And then as you can see, the volume, get volume is implemented and get area is also implemented. Okay, so we have to have a constructor. So here, int radius. Yeah, she's back here, but I'm not gonna open the door. And then public sphere, and then we only need a radius, right? Int r. Okay, let me make this one simple. And then here we say radius equals r. Okay, and then let me copy pi from the circle. Okay, we also can declare pi in the shape. Okay, and then have it for all the shapes. So here we can say, okay, oh, we forgot color, so we can also add color, but we don't need for now. And then here in the circle, since we have the shape there, we don't need to redefine it. And then here, what is the volume for the sphere? The volume is 4 divided by 3 times pi times r cubed, r times radius, sorry, not r. There's no r here. So radius times radius times radius. Okay, just to make sure, let me put parentheses here. And then the area is 4 times pi times radius square, right? So I can just copy from here. Okay. And then here in shape demo, we can create a shape 3D variable and then say s3 new and create a sphere. We cannot create a shape, right? Because a shape or shape 3D because it's an abstract class. So this cannot be created. An object cannot be instantiated from there, but we can have a sphere with radius 3. And then here we can just print out. We can just print out the sphere area and sphere volume. And then say here s3 dot area and then s3 dot get volume. Okay, and then if we print this one, here we see this, the area of the sphere is 113.04 and the volume is 8.78. Let's hope that this is correct. So 4/3 pi r cubed, right? 4/3 pi r cubed, very good. and then the area is 4 pi r square. Okay. If you have any objection, just let me know if it's wrong. And then let's also create a cube. So as you can see here again, okay, we'll go over it at the end. So let's create a cube which extends shape 3D, extends shape 3D, and then this one has of course has to implement the methods, and this one also has a constructor, public cube, and then if you have a cube, you just have one dimension, and then this is the same for all of them. Int a, and then here we can have int size, because that's the same for 3 of them. It's not height, width, or something else. It's size, and then we can say this dot size equals a, or just size equals a. I'll leave it this dot size. And here, what is the volume of the shape? The volume is size, size times size times size, right? So size cube. And then the area is 6 times size square, right? Let me see if anybody's suggested. Very good. Size square. Okay, and then here in the shape demo, I'll get a cool cube, and then they say S4, and then they say new cube, and then the size is 6, and then let's see what is the area, and then what is the volume. Okay, and then here say cube area, cube volume. Okay, just, oh, you see, we found a cool cube with the same area and volume. Okay, so we did all these things. So why do we need abstract class? Okay, so let's say we'll go in depth in collections, in list and array list and everything next week, probably on Monday. But just let me make an example. Okay, so let's say we have a list of shape 2D, and then let's name them shapes equals new array list, right? We can array list, and then just import list and array list. Okay, and then in shapes here we can just say shapes dot add, and then let me just comment out this lines and this one here. So we can create the object and edit here, and then say add S1, and then shapes dot add S2. So the first object and the second object 2D shape that we created. Okay, or we can just create and add to the list automatically. Okay, so just say new rectangle here and then new circle here. Okay, so you don't need to create a variable here and just assign. Just you can automatically just create the object and add it to the list. Okay, so create an object and add it to a list. Let's add a couple more. So shapes dot add a new rectangle with different dimensions, so it's 5 and 3. And then last but not least, shapes, let's add a new circle, circle with radius 3. Okay, so after we add it, as you can see, we can declare a list of shapes 2D. If we create a list of rectangles, we can only add rectangles in the list. So you see, you cannot add a circle, so you have to comment out this one, because you can only add rectangles to a list of rectangles. Okay, but if we say I want to add 2D shapes, okay, 2D shapes here, then we can say, okay, a list of 2D shapes, so I can add in this list circles and rectangles. And also, if I create a new class, which is a square, let's say, okay, let me just do it fast. Okay, new class, and then square, and then this also will extend shape 2D, and this one also has just the size, int size, and then we have a constructor public, and then say square, and then only given a font size. Okay, so size, actually you can say side, not size, but it's okay, no problem. Let me say side here, just one side of the square. Format so that we can see, and then also add the unimplemented methods, which is the get perimeter. So we want to get the perimeter of the square and the area of the square. So the perimeter of the square is, it's easy, 4 times side, right? And then the area of the square is 6. Oh, just 1 second. It's side times side. Side times side. Probably somebody just typed it here to help me. Okay, let me just check. Nobody helped me. Okay, I did it myself. Okay, so you see, I can do it without your help, guys. Okay, so we implemented a square, which is extends a 2D shape, which has to implement these two methods. And then here in the shape demo, we can add also a square here in between. So shapes dot add, and then new square, and then a square with side 5. And then after we're done with it, okay, so we can add multiple 2D shapes in the list. So when we're done with it, what can we do? We can have either we can do it a for loop, or we can do it an enhanced for loop, or you can do it with iterator. So there are different ways of doing it. I'm just going to do it with enhanced for loop. Okay, so for shape 2D in shapes, what did I do? Okay, declare shape. So when I'm iterating the shapes, I'm gonna find shape 2D, because as you can see there, I have list of shape 2D. So when I iterate the shapes, I'll get 2D shapes. Okay, so for each of them I can say, okay, let me just declare outside here, sorry, double total area equals 0, and then double total perimeter, if I know how to spell it, equals 0. Okay, so I said at the beginning there 0, so total area is equal to the total area plus shape dot get area. Okay, so I know that for each shape within the shapes, each of them has an area. Okay, so because all 2D shapes have area. Okay, and then also total perimeter is equal to total perimeter plus shape dot get perimeter. Okay, so as you can see, I can add multiple shapes in a shapes list. Okay, in a list, in a collection, and then I just, with this code, I can get the total area there. Okay, because every shape, every 2D shape, I don't care if it's a rectangle, if it's a circle, if it's a square, or if it's a triangle. Okay, let's do triangle. Just kidding, I'm not gonna do triangle now. You can do it yourself if you want to. So for every shape, you just need to get the area of the shape and the perimeter of the shape and add it to the total area and total perimeter. And when we're done, after the for loop, we just print out the, so total area is, and then total area, and then the same for the perimeter. Perimeter is, and then just total perimeter. Okay, so I just commented out everything else. I have done with this one. As you can see, so, oops. There's something wrong. I don't think the total area is, oh, we put this one here. Sorry, guys. It's in front of the equal sign. Okay. Okay, so total area is 104 and total perimeter is 87. You see, my math is good. I just understood that it was wrong. Okay, so as you can see, okay, I'll go in depth in the collections next week. Okay, but just as an example, we can have a list of 2D shapes, which is the parent of the 2D, all 2D shapes, rectangles, circles, and squares. And then after we create a list of shapes, which is an object of area list, and then we can add a rectangle, a circle, a square, another rectangle, another circle, and other things there. And then after we're done adding millions or billions of shapes, then we can just do a for loop, and they're saying that while I iterate the shapes, I'll get a 2D shape. Okay, so for each 2D shape inside the shapes list, I'll get the shape, and then each shape, it doesn't matter if it's a rectangle or circle or something, each shape has an area, each shape has a perimeter, and then we can add it to the total, and then at the end we can print the total. So I'm just waiting for you. I mean, you can do it after class. You can do the same thing. Let me write it down here. Do the same list example for 3D shapes. Okay, shape 3D. Shape 3D, okay? Or for 3D shapes. Let me do it this way. Okay, so you can do the same list example for 3D shapes, and at the end you can have the total area, total volume, and then you can print the total area. So as you can see, this is the power of having classes extending a 2D shape, because every class that extends this 2D shape, every class will have a perimeter, and also we'll have a area, and then for each of them, when we loop here in the list, we can get the area and perimeter. Okay, so do you have any questions? I'm waiting for your questions now. Okay, it is clear for some of you. Okay. Okay, so if there is anybody which says that it's not clear, just let me know. Okay, so this is for the abstract class. Okay, so if we have abstract class, let's now continue with interfaces, right? So if we have abstract classes, why do we need interfaces, right? Okay, so I think somebody is answering this one, and I don't need to continue. If you answer my question, then I'll just, oh, clear. I thought you were answering why do we need interfaces. Okay, so let's give a 10 minutes break, okay, for everybody. Very good. So 100% unimplemented class. Okay, so that's all for today. We already have the answer there. So let's have a 10 minutes break. Some people, they want to eat a sandwich. Some people want to drink some coffee. Some people want to pray. I don't know. Like, okay, I'll give 14 minutes. Okay, so I'll be back at 8:41, 8:45, sorry. Please don't answer everything, then I'll need to teach something. Okay, please, Frank Harvey. Okay, break. I'll do the same as Asel does. Break until 9:45. Okay, no, sorry, 8:45. Okay. Okay, I'll be back in 13 minutes. You lost 1 minute. Okay, I'm back. My other daughter wants to say hi. Good boy. Hi and bye.
Hi, bye.
Goodbye.
Bye.
Touching. Go to mommy. Go to mommy. Okay, Bessa, go to mommy. Run to mommy. Go to mommy. Bye bye. Okay. Okay, I have just 4. One of the daughters came 2 times. Okay, so I don't have 5. I have 4. I also have more. I have my wife. Okay. So I let you do the example of 3D shapes on your own. Okay. So I'm leaving everything here, and then you can do the same for 3D shapes. Thank you. Okay, so let's continue with the interfaces. So also interface is like abstract class. Okay. So let's have an interface. Let's say fruit. And then if you have a fruit, you can eat the fruit, right? Public. Sorry. Void eat. And then we don't implement it. Okay. So in the interface, all the methods that are in the interface are not implemented. Okay. So in abstract class, so let's go to okay, not this one because this has an unimplemented one, but for animal, for example, this is an abstract class. So as you can see, this has implemented methods and unimplemented methods. Okay. But for interfaces, okay, again the same logic. So we declare that if it's a fruit, then you can eat the fruit. Okay. But we don't declare how we eat the fruit. Okay. And then there might be other methods in the interface. Okay. And then let's have a class. So again, for interfaces, another interface can extend an interface. Okay. So let's say, I don't know how to spell exotic. I believe it's exotic like this. Is this how you spell exotic? Yeah, exotic fruit. Okay. And then public interface. And then this one extends fruit. Okay. You can declare another method here, or you can just leave it empty. So as you can see, an interface can extend another interface. Okay, so that's the first thing, that interfaces can extend each other. But if you have a fruit here, let's say now we know that, okay, if it's a fruit, then let's say apple. And then this fruit, this is a class, apple. This implements, this cannot extend, this can implement fruit. Okay. So if apple implements fruit, again, we have to implement the method. Okay, the same thing, the same logic with abstract class. So if you have a method, if we have a method in the interface, it has to be implemented in the class. Okay, so here we can say wash and then eat. Okay, some people, they peel the apple, but doesn't matter. Okay, we just wash and eat because we believe that in the in the skin of the apple, there are all the vitamins, right? That's what they told us. I don't know if it's true. Okay, so, and then let's have a class. Fruit demo. Okay, fruit demo. And then I don't forget, this time I have to add a main class, the main method, sorry. So in the main method, I can, again, as I did with the abstract class, fruit A for apple equals new apple. Okay, so you can create an object of the apple, but you cannot create an object of the fruit. Okay, can we create an object of the fruit? No, because fruit is an interface. You cannot create an object from the interface. You cannot instantiate the fruit. Okay, the same with the abstract class, but we can create an apple. Sorry, I don't know why this opens. Okay, so we can create an apple, and then what if we want this apple to implement, or let's say we can, you know what? Let's change the example here. So fruit can be an abstract class. Okay, abstract class, and then public abstract eat. Okay, and then we don't need this one. So let me just delete. We learned about this one. And then here in the apple, we say apple extends. Okay, extends because apple extends fruit. So when we say abstract class, generally in inheritance, if a class extends another class, we say this one is a parent. Okay, so apple is a fruit. Okay, so the same for a shape. A rectangle is a 2D shape. And then if we go to 2D shape, a shape 2D is a shape. Okay, so for if we have an inheritance, we can say is. Okay, we can do it with with the interfaces, but generally in interfaces we say can. So apple can do something, or apple is eatable, apple is washable. Okay, so let's add a washable interface. Okay, so sorry, new interface, and then say washable, and then if it's washable, so you have to wash it, right? Public void, and then wash. So if it's an interface, you don't have to implement it. Okay, so we have the wash method. So you mean that if every fruit that implements the wash method will say, let's say, wash the fruit. Okay, and then let's have another one. Okay, fruits can be washable, can be peelable, right? So you can peel the fruit. Peelable. Okay, I had to say interface, but it's okay. Okay, interface. So, and then public void peel, right? And then what else? What else can we do with the fruit? Can you suggest something else besides my daughter is so cute? Anything else you can do with the fruit? Do you have any suggestions? Let's say, oh, somebody's a cut, right? Okay. New interface. Let's say cuttable, right? I don't know if it's a thing, but cuttable. Okay. Cutable. Okay. And then again, public void cut. Okay. So also we can have another interface, crackable, right? Because sometimes you crack the shell of the, so new interface and then crackable. Okay, so this is just my smart idea. Public void crack. Okay, so you can crack the fruit. Okay, and then jammable. Okay, yeah, we can continue. So you can add some examples. So as you can see, there are a lot of interfaces. Okay, so this is not cutable, it's cuttable, and this is peelable. Okay, so you can peel the fruit. Okay, also you can say can peel. Okay, and then now we have apple here. Okay, of course apple extends fruit because apple is a fruit, but also implements. Can we wash the apple? Yeah, we wash before we eat, right? So washable. And then we can peel. Yeah, some people peel the, I don't suggest you to peel the apple, but you can peel the apple. And also we can cut, right? So as you can see now, this apple, as you can see, this class can only extend one abstract class or one class, but it can implement many interfaces. Okay, so that's the power of interfaces. So it allows you in Java, we don't allow multiple inheritance, but we allow multiple inheritance through implementation, through interfaces. Okay, so this apple now has to implement all these methods, that since it's implementing washable, so it has to implement the wash method. Okay, so different fruits, they can implement different interfaces, and they can implement them in different ways, but of course we have to have the washable. Okay, so wash the apple. Okay, the apple, I say apple sometimes, I'm sorry. Okay, apple, and then peel the apple and then cut, right? Cut the apple in pieces. Okay. And then here in the fruit demo, after we create an apple object, and then we can say, okay, apple dot, you can eat the apple because it was in the, so it was in the fruit abstract class. Okay, so since fruit is an abstract class, is a parent of apple, so here we have eat method. Okay, and this eat method has to be implemented in the apple class. Okay, so here eat, we implement it this way, we wash then eat. Okay, so we have to, let's say, okay, so we can do this way. So before before to eat the apple, we can say, let's wash it first. Okay, wash and then eat. Okay, so since we washed with a different method, eat the apple. Okay, so first we wash the apple and then eat the apple. Okay, so we can call another method within this class. Okay, so in fruit demo, we can say eat the apple, we can say apple dot, so since this is a fruit, so as you can see, we only can call the eat method. Okay, if it is a type of apple, then we can call the other methods. Okay, so wash or peel and then apple dot cut, right? But if we use the fruit, if we use the fruit type of variable, so as you can see here, we only can eat the fruit, because we know that fruit, we can eat it. But if you want to peel that, this one has to implement the peel, the peelable interface. Okay, so before we peel, we can say peelable p equals, so let's okay, let's run this example. So as you can see, first of all, after we create an apple, which is a type of fruit, then we can eat the apple. Okay, so if we eat the apple, just let's comment out these other things. So if you just eat the apple, so first we wash the apple and then eat the apple. Why? Because if you go to the eat method, which is in the apple class, sorry. So if you go to eat method, so first we wash. So we wash the apple first, it's here, and then we eat the apple. Okay, so these two comments are written in this method. And then after we're done with eating the apple, we can also peel the apple. Okay, so we create a peelable variable, and then we can cast from apple to peelable. So we have to go through this through these concepts again, but that's how we do it. And then so we can convert an apple, since it is this apple is implementing the peelable interface. So it means that you can convert this object to a peelable, okay? Because this object is of type apple, although it is stored in a fruit variable, okay? So we can convert it to peelable, and then we can peel it, okay? Because if it's peelable, then we can use, or we can convert it to apple, because this is an apple object, although it is stored in a fruit variable. So we can convert it to apple, and then since apple is peelable, then we can peel it. Okay, let's see, peel the apple. Okay, is there any questions here? I'm gonna wait 2 minutes for your, if there's any question or something, or if it's clear, you can just say clear or say nothing. Because I need to make sure that everything is clear before I go on. Okay, so if anybody didn't get something, please say, can you repeat it, or can you please explain it a different way? Don't be shy. Don't hesitate to ask questions. Okay, if somebody makes fun of you, I'll make fun of him. Okay, so nobody will make fun of you. You can ask any questions. Don't think there are no wrong questions. Okay. So exotic fruit, we just deleted that one because we didn't need it. That was just an example to show that an interface can extend another interface. Since we changed fruit from interface to abstract class, so that's why we cannot extend this one anymore from exotic fruit. So we can just have another abstract class, exotic fruit, and then just extend this fruit. Okay, so this is a good question. Can we convert any object into another type of object? Okay. Yes. So Mr. Asim has always the same problem. So let me just remove the animals and sorry. And okay. So we only have fruit example. Okay, here. So again, let's go step by step. So fruit is an abstract class. Okay, and it has an abstract method. And then apple is extending the fruit class, which is an abstract class. So this apple has to implement the eat method, okay? And also apple is implementing washable, peelable, and cuttable interfaces, okay? So each of them has a method. So washable has wash interface, peelable has peel method, sorry, not interface, but method, and then cuttable has cut method, okay? So this class is extending one class and is implementing 3 other interfaces. Okay, so you see washable has just one method, peelable has just one method, and then cuttable has just one method. Okay, so I like to format the code, so just let me format the code. Okay, and then crackable, we didn't use it because we cannot crack the apple, right? But if we have something else, we can crack if we have a nut. Okay, so that's all we have. Okay, so apple, this is the most important thing. Apple is a fruit, and can be washable, can be peelable, can be cuttable. Okay, you can cut the apple, so you have to implement, you have to do whatever you're saying that you're going to do. So let's come to the question: can we convert an object? What was that? Can we convert an object to any other type of object? No, we cannot. So if we say, okay, let's convert this one to animal, right? You see, this one this object, which is a fruit, cannot be casted into animal because there is no relation. The only way is that if you have an object of apple, you are automatically casting this one to a fruit. Okay, this is upcasting. Okay, so you are casting the apple object, so you have an apple actually, so you can also do it in 2 steps. So say apple, and then say fruit f equals then is equals a. So what are you doing here? You're assigning this apple to the fruit. Okay, so instead of doing this in 2 steps, we're just automatically just creating the fruit here. Okay, saying, okay, sorry, we have a variable of type fruit, so anything that is a child of the fruit, which is an apple, and then we'll have other fruits there, so we can have oranges and bananas and everything. So every class that is extending the class of fruit can be upcasted to the fruit. Okay, so we know that we have an object of apple, but we keep it as a fruit. Okay, so we're saying, okay, this is a wrapper, fruit wrapper, and then we can put there an apple. So if you have a basket, let's say a basket, and then I have a fruit inside, that's what it's saying, and then you can put the apple there, right? Is it a fruit? Yes, it is. And then take it out, and then we can get a banana, put it in the basket, and then we say I have a fruit. So I have a fruit, which is an apple. I have a fruit, which is a banana. Okay, whenever we create the banana class. Okay, so for now, so we can upcast the child class to parent class. This is one thing. And the second thing is, although apple, although this is type fruit, but actually inside is an apple, so we can just, let's say, unwrap it. Okay, unwrap this fruit and have the apple back. I want the apple back. Okay, so just unwrap it, get the apple. Okay, so this is called downcasting. So it is, you're moving from parent class, you're casting it to a child class, but you cannot cast it to animal or to cat or to dog or anything else, because there is no relation between the fruit and the animal. So here, if you say animal, then it will say here type mismatch, you cannot convert animal to apple. Okay, so because there's no relation between them, but of course you can convert it to apple. And then if you convert it to apple, what did we say? So we have an apple and we can convert it to a fruit. Why? Because fruit is an apple, but fruit also is, this fruit here is peelable, because we said that this fruit apple is peelable. So we can say, okay, now we have, let me say this one, A2. Okay, now we have an apple, or let me say just apple. Okay, and then now you can say, okay, peelable, P equals, and then now we can cast from apple to peelable. Okay, so actually you can also say A here. Okay, so we have to say that I want, no, not apple. We can say apple to peelable, sorry. So here again is an upcasting. So you're casting from apple, which is a type apple. You can cast this one to peelable. You also can cast this one but you have to say here because you're downcasting first. Okay, so you say peelable P2 equals, and then A. Okay, so also here you can say peelable, but you don't need to, because apple is already, apple, if you go to apple class, is already a type of peelable. Okay, so you don't need to say here because this is upcasting. Upcasting is done automatically, but downcasting, you see, because this is a fruit, so you have to be an apple first and then to be peelable. So downcasting is you have to declare it. Okay, so I'm going to comment out because we don't need these things here. Okay, so we have a fruit here, and then if we want to peel it, we can just change it to apple and then peel it. Okay, because you don't know if we don't know if a fruit is peelable. We just know that the fruit is eatable. Okay, so you can just eat the fruit, but you cannot peel the fruit. Okay, is there any other question? I know you'll say it's all clear, but yeah, actually, I know what you're gonna say. Okay, so let's continue. We said that the fruit. Okay, let's create another fruit here. Okay, or okay, let's continue here. Okay, and then convert the fruit to apple. Okay, or let me just say F1 here so that the names are F1, and then convert F1 to apple. Okay, so you're converting the first fruit to apple, and here we're gonna say this one. Okay, and then here you can say apple, because if it's an apple, then you can peel. If it's an apple, then you can cut, and so on. And then if it's an apple, you also can wash. Okay, so here, so these two comments are from this one. Before we eat, we peel. Sorry, before we eat, we wash, and then we peel and cut an apple. Okay, so let's have another fruit. Okay, so again, the same example, or I'm gonna ask you to do orange and banana. Okay, so orange, let's see if we can do, while I'm writing it here, I want somebody to say done. Okay, so orange and then banana. Oops. Okay, so orange will also extend fruit and will implement, what will orange implement? So it's peelable. Do you wash? We don't wash the, right? But we can cut it. So it's cuttable and then peelable. And banana is peelable, and we don't cut banana. We just eat it, and we don't wash banana. Okay. So is anybody done? I'm gonna give 10 minutes, but if somebody is done, then I can just take it down to 5 minutes. Okay, so are we good? Should we continue? I see the number of students dropping from 40 to 35. I feel so bad for them, not for me. So, okay, let me give you less than 10 minutes, okay, up to 9:23. So I'm gonna give just 9 minutes. And then we're gonna implement together the orange and banana, and maybe also one nut, walnut, right? And walnut, because walnut is crackable, right? So these are the 3 classes that need to be implemented in the near future. I hope somebody says done here. Okay, I'm gonna wait for the question, and then I'll go down to kiss my daughters. Okay, she has a long question. Okay, so I'll give you less than 10 minutes. Okay, at 23, I'll be back. Okay, I'm back. I have no more kids, so I'm done with the kids. Okay, let me see if there is any suggestion there in the Slack. Okay, everything all right. So let's continue with a orange, banana, walnut example. So I'll do orange. So let's create a new class which extends. Thank you for doing it. This is orange. Okay. So this again, same as apple, will extend only one class, which is fruit, and cannot extend more than one class. And then implements. So orange is washable. No, we don't wash orange, right? But we can peel it. It's peelable and cuttable, right? Because there are people who cut the orange. And then here there are a lot of unimplemented methods. So it is eat from the abstract class. So how do you do in apple? You said eat the apple, cut the apple, peel the apple. Okay, and then here we say eat the orange, and then peel the orange. Peel the orange and also cut the orange, right? Okay, and let's also implement walnut. So new class walnut, and then this one extends fruit, because also walnut is considered a fruit, I believe, because you can eat it. And then implement. So we can peel. No, we cannot peel walnut. We cannot cut it. We cannot wash it, but we can crack it, right? Just crackable. Just crackable. And then we have to implement two methods: one from the fruit, and then one coming from the crackable interface. And also we have jammable interface to make jam. Okay, somebody suggested jammable. So crack the walnut. And then eat the walnut. And then in the fruit demo, let me delete these things. So we have this peelable. I'm not going to remove this down castings. So let's say we have a fruit, but all we can do with the fruit is eat. We cannot peel it, we cannot cut it, we can wash it, you cannot crack it. Okay, just if we create a fruit, then the only method that we can call is eat, right? So fruit f2 and then new. Okay, so let's do the same example that we did with what was it, with the shapes, right? So let me create a list of fruits. Okay, so list of fruits. Okay, so let me call them fruits, and then they say new array list. Array list. And then they just import Java util. And then they say, okay, fruits dot add, so we can add a fruit, which is the apple, F1. We created the apple there, and then fruits dot add, and then we can create a fruit and add it directly, new banana. Oh, we didn't do banana, right? We did walnut and orange. So fruit, orange, and then fruit dot add new walnut. Let's believe that walnut is a fruit, because there are people that don't think that walnut is a fruit. And then let's add another orange, right? Orange. So we have two oranges, one walnut and one apple, and then the last one, another apple. Fruits dot add new apple. And then when we eat, and then just here, when we eat this orange and walnut, before we eat the orange, we can peel, right? So just peel. We can call this method, which is itself. This is the method that is from the peelable interface, and then it's implemented here. And then in walnut, before we eat, we have to crack it, right? So we crack and then eat it, right? Okay. Okay. And then in fruit demo, so after we added multiple fruits in the list, so we have a collection. We'll go through the collections next week, but this is the easy thing. So we have a collection of fruits, okay? And then we added, like, let's say we have the music CD collection, right? And also we have fruits collection. So we have, like, let's say a bag of fruits. So inside you can add an apple, a walnut, orange, another fruit, like another apple, another orange, okay? And then after it's full of fruits, we can just get one of them with our closed eyes, and then we can eat. We know that if there are fruits inside, we can eat each of them, okay? So let's go with a for loop. I'll go with other loops next week. I don't want to change it. So when I am iterating fruits, so that's how I like to explain this one, okay? So when I am iterating fruits, I will find a fruit, okay? So every time I iterate it, I'll get one fruit, right? So fruit F, let's say, or let's say fruit. So when I iterate fruits, I find a fruit, and then let me just go in it. And then for each fruit, I can eat. I know that there is the eat method for each fruit, okay? And then let me just comment out these other things here, okay? And then when we run this one, as you can see, so we added the apple, the orange, walnut, orange, apple, and then as you can see, so before we eat the apple, so after each one, I just, let me write here something so that we split between done with it, done with the, or let's say finish the fruit, done with the fruit, done with the fruit, okay? And then let's do another fruit, okay? Okay, so this is just to split between fruits. Okay, so I wash the apple, I eat the apple, I'm done with the fruit. I peel the orange, I eat the orange, done with the fruit. And then again, the same, crack the walnut, eat the walnut, done with the fruit, and then peel orange. So as you can see, I can add multiple fruits in the list. It can be a different type, since each of them extends the fruit abstract class. So we can create an object of the classes that extend the fruit class. So it is orange extends the fruit class, walnut and apple extend the fruit class. So you can create an object of orange, walnut, or apple, and then we can add it to the fruit basket, let's say, or fruit bag. Okay, and then after that, after we iterate through the basket and then just get a fruit, we done with it, get another fruit, eat. That's what I tell my kids, right? Don't start another fruit without finish the first fruit. Okay, so what are the differences? So if we have abstract class, why do we need interface? Or if we have interface, why do we need abstract class, right? So the first and the most important thing, let me go here for apple. The most important, so one of the fruits, apple, okay? The most important things between abstract class and interface is that abstract class is a class, so you can only extend one. You can only inherit from one abstract class. But if we're talking about interfaces, we can implement many interfaces. Okay, so this class, Apple class, can extend only one abstract class, but can implement many or none of interfaces. Okay, so and then you have to implement each methods that are not implemented in the interfaces, or each of the abstract class, each of the abstract methods of the abstract class. Okay, so this is the most important thing. So Java allows, let's say, inheritance through interfaces, through implementing interfaces. One. The second thing is that abstract class can have, let me go to the other example, to the animal example, right? So this is an abstract class. So this one has implemented methods. When we know that this method will be implemented the same for all the classes that are extending this one. And we have unimplemented methods, which we don't know. We just say, okay, if we're going to extend me, if you're going to be an animal, you have to say how you talk and you have to say how you move, because I don't know how you move and how you talk. I know that you sleep and you eat. Just close your eyes and sleep, or just move your mouth and eat. But for talking is different, because animal talks in a different way, and every animal talks in a moves in a different way. Okay, so abstract classes can have implemented and unimplemented methods, but interfaces can only have unimplemented methods. Can have any number. Okay, so we can have wash here, we can have others, but this was the example. So this can have any number of unimplemented methods, and it cannot have implemented methods. Another thing, so here you don't have to say public abstract. Okay, I don't know how to spell abstract. So you don't have, because Java automatically does it for you. So you can do it, but even if you don't do it, Java will automatically do, because this is an abstract method. Okay, you don't have to say it, because if it's an interface, this is a contract having only unimplemented methods, abstract methods. Okay, and also I have a quick question for you. Okay, here in the animal class, can I make this, if this is an abstract class, can I make this method private? This, I need yes or no, quick yes or no answers in the no. Okay, you say no. Is there anybody who says yes? I'm gonna wait for 30 seconds. Some people say no and yes. Other people started changing from no to yes. Okay, so yeah, people, they changed their mind. Okay, yes. So we can have a private implemented method. What about another question now? Okay, so I know there are people still answering the first question. I don't know if I can. I'll try to make a poll next time. Okay, so I have a poll there, and then try to have answers. Okay, so now I have another. Okay, I'm done with this one. I'm gonna say done here. Okay, and then I have another question. Can I make this method private? What do you think? Yes or no? But please don't change your mind, okay, Mr. Frank and Asimabe? No. Okay, and then let's say why no. Is there anybody who says yes? Can we change this method to private? Because we said yes. This one, we can change this one to private. Why I cannot change this one to private? Oh, Java already gives me an error here. It says, what does it say? Let me see. Okay, let's see here. The abstract method talk. The abstract method talk in type animal can only set a visible modifier, public or protected. Okay, what does it mean? So if this method is private, it means that this one cannot be seen. This one cannot be seen in the child classes. Okay, if it's protected, I'm not gonna go with questions because I can say, can this one be protected, and then can this one? If it's protected, yes, we can say this one protected. I'm not gonna ask, because this one, if it's protected, it means that child classes can see this method. Okay, so in the child classes that I will implement this method, I can see this one. If I say public, yes, of course I can say public because it can be seen from everywhere. But if I say private, then this one it is not possible because I cannot see this one through my child class. How? And then this will remain unimplemented because my child classes will not see the talk. You see here, if I say save this one, and if I go to any animal, cat, you see talk here. Okay, let me just remove override. So talk is just another method here. You see, it's not overwriting because you cannot see talk method in the parent. Okay, so that's the beauty of override. So override says that you are overriding talk method in the parent class, but you cannot see the talk method in the parent class. So there is, according to cat, there is no talk method in the parent class because she cannot see it, or he cannot see it. Okay, so that's why override here is not possible. But if I comment out this one, okay, it allows me to do this one because because it means that yes, I'm just having a new method here, talk method. Yes, I can have a method which is talk, which is not in my parent class because I cannot see the talk method in my parent class. Okay, so if I just remove this one, move it back to protected or public. So generally it's suggested to have protected because in the child classes this one will be seen. And then here, if I go to the cat, or the cat, okay, you see you're overwriting the talk. I mean, you're implementing it, but also you're overwriting the talk method in the parent class. Okay, so you're overwriting that one. So let's repeat this one. So we were in animal class. So in animal class, we can make this one private, but of course, if we make it private, this can only be seen within this method. So here you can call sleep here. Yes, you can call before eating, you can sleep, or vice versa, whatever. So you can call this one within the class, but we cannot call it through the child, so we cannot call it from outside. But you cannot make this one private because if you make it private, it cannot be seen from the child classes from anywhere. So that's why it will remain unimplemented. Okay, what's the problem here? Sleep. Okay, I'll make sleep public again, and then you'll be okay. Yeah, in an online class, I feel like talking to myself. It's a little bit funny and weird. Okay, because I cannot hear anything from you. But anyways, I believe you're listening to me. Okay, so and also another good example is that like listener. Let me go to. I think we use listener in test-ng. Can somebody remind me where when we used listeners? Test-ng framework. I think it's here, and then Java utils, and then listener here. Yeah. Okay. Okay, very good. Thank you. So as you can see, any class here, which we called it listeners, is extending the base class. We don't care because it's just extending this class because it needs something from that class, the driver probably, and also is implementing iTestListener. So you have used this one. So I'm giving you an example from the things that you use. So iTestListener, generally when we're talking about interfaces, some people they prefer to use I in the beginning, and sometimes they prefer to use able at the end, so washable, peelable, or sometimes they prefer to use can, like for example, if you have a car, can drive or drivable, and then can wash, whatever. So anyways, here in the listener interface, you see this listener interface is extending another interface, which has something else there. And then if you want to implement me, if you want to extend me, actually you cannot extend, but you can implement an interface. If you want to implement me, you have to implement on-test start, you have to implement on-test success, on-test failure, on-test skipped, on-test whatever. Okay, so you have to implement these methods. Okay, that's what it means. So if you go to the listener here, as you can see, you implement on test start, on test success, on test failure, and the other methods. Okay, so it means that whenever a test will start, this listener, whenever a test will start, this listener will listen to it and then will run this one when the test starts, and then if the test succeeds, the listener will listen to this one. Okay, so this interface is implemented by this class, which has to implement the methods that are defined here. Okay, are declared here. So these are the methods that are declared. He's saying if you want to implement me, you have to implement these methods. Okay. Okay, so this is one of the things that you have used. The second thing that you have used was the list. So in Fruit demo and also in the other demo in the barn, we had a list. So this one was also an interface. So list is an interface. So whatever class, so list says, okay, if you are a list, you should have a size. If you are a list, I can check. I mean, you can be checked if you're empty. If you're a list, they can check if you contain something, and then if you're a list, you have an iterator. Okay, so and then here in the example, let me go to Fruit demo. Okay, so this list is implemented by this class. Okay, that's why we're using here. So you're creating an object of area list and you're storing in a list, or you can also store it in an area list. It's the same thing. But if you want to change it later, then you can use the list. Okay, so here is saying, okay, I have implemented area list should implement. Let me find. So area list is a class which extends abstract list, so it extends something, and also implements list. So this is the thing that I want to emphasize. Okay, so as you can see again, area list extends one class, and area list implements many interfaces. So one of them is list. So if you're going to implement the list, so you'll have the size. Okay, so you'll have the size method. Let me find it. Okay, somewhere there. And then, okay, I can find it from here probably. Okay. Okay, I have the add. So if you're a list, you can add in the list. If you're a list, you can check. You can let me check here. Fruit dot size. Okay. And then if I go here, of course I go to the interface because that's an interface. So if I make this one area list, and then if I go to size, then I go to the, so as you can see, I have a size interface. So I have a size method which implements the size method in the interface. So this is an abstract one, and and this one area list implements that one. Okay, so let me just put this one back. Oops. Okay. Okay, so these are two examples, and then another example that I'll give you as an homework. Maybe later I'll prepare it. So I'll let me wrap up now because we have only 10 minutes and I don't want to start with another example. I can give another example as a not homework but as a thing to do extra exercise. Okay, but for now let's just wrap everything. Okay, so today we learned about abstract classes and interfaces. Okay, so both abstract classes and interfaces are abstraction of object-oriented programming concept. So you have inheritance, so you have a child class and the parent class. So the parent class can be abstract class, which has some implemented methods and some unimplemented methods, or can be an interface which has many unimplemented methods. And then if it's an interface, then you can implement many interfaces. You can implement any interfaces, but if it's an abstract class or any other concrete class, you can only extend one. Okay, so that's the main difference between those two. And also the thing is that you cannot create an object from interface and you cannot create an object from abstract class, because those are abstract concepts. They are just concepts. So you can say, okay, that's an animal, but can you create an animal? No, you can create a dog, you can create a cat, but you cannot create an animal. And then just for you to be clear, so I'll push the code. You can pull the code later. One. The second thing is that probably the video is being recorded. I hope so. And then it will be shared with you. So some people who weren't able to join this one, I hope they don't share the video. I don't want other people to watch it because they have to join the class. Just kidding. So the video will be shared. And then if you have any questions, I'll try to answer. I don't know, I'm on vacation, but I'll try to answer any questions, and I'll try to give you an example with a smartphone and then iPhone, which extends the smartphone, and then let's say Android, which also extends the smartphone, and then you have a repair shop when you can give a phone to repair. Okay, you can give a smartphone and they repair it. So I'll try to put the example and give it to you. Okay, thank you for listening. Have a good night. See you on Monday. Thank you.